All right, today we're jumping into one of the most, truly audacious climate engineering ideas I've ever come across. It's a plan that ties together two continents and two massive environmental crises in a way you'd never expect.
So, let me just ask you this. What if planting trees in Africa could save cities in America? Really think about that. What if a massive reforestation project right on the coast of the Saharan Desert could actually dial down the destructive power of hurricanes hitting places like Miami and New Orleans? It sounds like something straight out of sci-fi, but the science behind it is, well, it's absolutely fascinating.
Okay, so to really get how this all connects, we need to look at two problems that, on the surface, seem totally separate, happening thousands of miles apart.
So on one side of the Atlantic, you've got the Americas, right? Where these monster hurricanes just slam into major coastal cities, causing billions and billions of dollars in damage. Then you look to the other side, in North Africa, and you see the Sahara Desert just relentlessly spreading. This causes drought, food shortages, and it forces millions of people to leave their homes. Two absolutely huge crises, and yeah, both are being supercharged by climate change.
So what's the big idea to fix this? It's called the Saharan Coastal Greening Initiative, and at its core, the idea is to build this massive, nature-based climate defense system. We're talking a giant forest on the edge of the desert that could, in theory, tackle both of these huge problems at the same time. Okay, but this is where the whole thing gets really interesting, because the relationship between the Sahara Desert and Atlantic hurricanes is not at all what you might think. Let's break this paradox down.
All right, let's meet the star of our show, the Saharan Air Layer, or SAL for short. So what is it? It's this massive body of hot, dry, and incredibly dusty air that forms over the desert. And then it travels west, right across the Atlantic, floating directly over the very places where hurricanes are born. Now here's the wild part. The Sahara, just as it is right now, this giant desert, actually acts as a natural break on hurricanes. It's incredible. First, all that dust in the air reflects sunlight, which helps cool the ocean's surface below. Then, that super dry air literally starves developing storms of the moisture they need to grow. And finally, the strong winds that come with the SAL create something called wind shear, which basically tears young storms apart before they can even get organized. So the desert is kind of an accidental hero here. So this brings us to a really critical and kind of counterintuitive question. If all that dust and dry air from the desert is currently weakening hurricanes, wouldn't planting a giant forest, which would cut down on dust and add moisture, actually make hurricanes worse? And the surprising answer is, yeah, it absolutely could. If you just went out and planted trees randomly, you could totally backfire and accidentally create a superhighway for even stronger storms. But the people behind this plan, they've thought of that.
So, here's the crucial point. This isn't just about planting a bunch of trees, it's about precision planting. We're talking about using advanced AI climate models to pinpoint these super strategic zones along the coast. The whole goal is to place forests in just the right spots to disrupt something called African easterly waves. You can think of these waves as these little atmospheric ripples that are basically the seeds for hurricanes. So by carefully placing these forests, the idea is to weaken those seeds right at the source without getting rid of that natural hurricane blocking effect from the Saharan air layer. It's a really clever balancing act.
All right, so we've covered the why. It's a pretty wild concept. Now let's dig into the how. How on earth do you plant a massive forest in one of the driest places on the planet? Okay, so the project would be focused on the northwest African coastline. We're talking primarily about countries like Mauritania and Senegal, where the conditions are, most favorable to get a pilot project off the ground. But from there, it could potentially expand. And the scale we're talking about here is just enormous. Tens of thousands of square kilometers of new forest.
So how do they pull this off? Well, the whole plan relies on a whole suite of modern technologies. First, you plant super hardy, salt-tolerant trees, like acacia. Then, for water, and this is key, you'd use solar-powered desalination plants, pulling water straight from the Atlantic. This water would be used super efficiently with drip irrigation systems monitored by AI sensors. And here's the really clever part. The massive solar farms needed to power all this could also generate surplus electricity to sell, creating a kind of self-financing loop to help pay for it all.
Of course, a project this big comes with a pretty massive price tag. And that brings us to the multi-trillion-dollar question. Could an investment of this size actually be worth it?
Well, to put the cost into perspective, let's just look at the price of doing nothing. A single powerful hurricane, think something like Katrina or Harvey,
can cause over $100 billion in damages. One storm.
And that is the absolute core of the economic argument. If this whole project manages to weaken or even just deflect 10% of major storms over, say, 2 decades, the projected savings from damages that didn't happen could be upwards of $300 billion. That would totally dwarf the initial investment. You see, it's a huge shift from just reacting and spending money on disaster recovery to proactively spending money on disaster prevention.
But wait, the return on investment isn't just about the money saved from hurricanes. The co-benefits for Africa would be, well, they'd be transformative. We're talking millions of new jobs in things like forestry and tech. We're talking about improved food security for over 80 million people in the Sahel region. You'd see less pressure for climate-driven migration, and on top of all of that, you'd be capturing hundreds of millions of tons of CO2 from the atmosphere. It's a huge win-win.
So, okay, the vision is powerful, and the numbers, they're pretty compelling. But what would it actually take to turn this massive dream into a reality? Yeah, we've got to be realistic here. The challenges are just immense. The amount of water and energy required is staggering. A lot of the countries we're talking about face political instability and, governance issues. Then there are the ecological risks to think about. I mean, introducing new species on this kind of scale could have all sorts of unforeseen consequences. And, of course, the whole thing would require a level of international cooperation we've almost never seen before.
But the path forward isn't just, let's do it all at once. The implementation roadmap is actually broken down into phases. It would start with smaller, more manageable pilot projects in more stable places like Mauritania and Senegal. These pilots would be used to test the technology and fine-tune those climate models. Only after they've proven the concept works would it start to expand, bringing in huge global partners like the World Bank and even NASA to scale things up responsibly.
When you really get down to it, this project is about a fundamental shift in how we think about climate adaptation. Instead of just building higher seawalls after the fact, it suggests we can go right to the source and actually shape the very systems that create these disasters in the first place. It's a really bold, proactive vision that's basically asking us to stop just reacting to climate change and instead start architecting a more resilient future. So the question is this the kind of ambitious, large-scale thinking we really need to face our climate future, or is it a step too far into engineering our own planet?